Today we will go over the rest of the problems that we didn't get to in class. So number 4, we did number 4 in class, but I can do it again for you. So the first thing I need to do, according to PEMDAS, is get rid of the parentheses. So remember, the sign is part of the number, and I have to give it to each piece in the parentheses. So here I get negative 8x minus 12. I bring down the rest of the things from the top, and now I combine my like terms. Make sure you draw the box around your like terms. So the green are my variables, and the orange are the constants. Now remember, if there's no sign, that doesn't look good. It's positive. So here I combine and I get negative 8x plus 10x gives me positive 2x. Positive 6 minus 12 gives me negative 6. There's no more terms I can combine. The answer is 2x minus 6. Number 5, I do the same thing here. I want to get rid of the parentheses. So I go to the innermost parentheses, and I know that this parentheses here is distributing a 1 to each piece. So I can just ignore those parentheses. They don't mean anything. Now I bring down the rest of the things, and I'm left with this. So now I need to get rid of these parentheses. So I will distribute the negative 10 to each piece in the parentheses. And I will get negative 10x minus 20x plus 30. I bring down the rest of the pieces here, and now I draw a box around my like terms. The variables will get a green box, and I make sure that I include the signs. I draw a box around the constants. Remember, if there's no sign, it's positive. And now I combine. I get positive 4 plus 30 is positive 34. Negative 10x minus 20x plus 12x is negative 30 plus 12 gives me negative 18x. There's no other like terms I can combine. My answer is negative 18x plus 34. Let's do number 6. Number 6. I want to get rid of the parentheses first. I distribute. I get 3x minus 6x plus 18x. I bring down the rest. Minus xy plus y squared plus 2y squared. And now I draw boxes around my like terms. I have x, x, x. Here I have negative xy. And then here I have y squared. So let's go through everything. For the x's, I get plus 3 minus 6 gives me negative 3 plus 18 gives me 15x. There's no other xy to combine, so I just bring that down. I combine the y squareds. I get 1y squared plus 2y squared gives me 3y squared. There's nothing else I can combine. My answer is 15x minus xy plus 3y squared. Let's do number 7. First, I want to get rid of the parentheses. I give 1 to each piece inside. I get 3x plus 4x. This is in parentheses. I bring down the rest of my things. I want to combine the like terms in the parentheses. I get 3x plus 4x gives me 7x. I bring down the rest of the things. I want to get rid of the other set of parentheses. I get 21x. Oh wait, no, 21. No, that's not 21, sorry. I get 7x squared plus 21. There's nothing else I can combine. My answer is 7x squared plus 21. Let's do the next one. Number 8. What is the student's mistake in the problem below? What is a mistake? It means where the student made an error in solving. So what do we always do when we're trying to find which student is right, where the student made a mistake? We always solve it ourselves first, and then we compare the work. So let's solve this problem ourselves first. So first I want to get rid of the parentheses, so I distribute the -4 to each piece. I get negative 8x minus 12. I bring down the rest of the pieces. I draw an X around a box around my like terms. And then I combine. Negative 8 plus 10 gives me positive 2x. 6 minus 12 gives me negative 6. And that is it. There's nothing else that I can combine here. Also, the question tells me to simplify. Therefore, there is no equal sign, and I will not be getting an answer. So the student's answer should be 2x minus 6. The student got this piece here, but then he did this weird thing where he added an equal sign and solved the problem. You can't do that. That is an error. The student's mistake is right here. So what did the student do? The student added an equal sign. You can't do that. That doesn't make any sense. This is wrong because the student added an equal sign when the student should have simplified the expression. So let's try solving these. Look at the word here. They say solve. That means I will have an equal sign here, and my answer will look like x equals, okay? So let's go ahead and solve these. First, I need to get rid of the parentheses. So I distribute the 2 to each piece in the parentheses. I get 2x plus 6 equals 4 minus, I need to distribute this negative 1 to each piece in the parentheses. I get 4 minus 2 plus x. And now I put a box around the like terms. Oops, that looks bad. And I combine. 4 minus 2 gives me 2 plus x equals 2x plus 6. So now I need to put my line. I need to move the constant to get x by itself. And here I get 2x equals 2 minus 6 gives me negative 4 plus x. I need to send this x over with the other x, and I get 2x minus x gives me x equals negative 4. And that's my answer right here. Number 10. First, I draw my line. Then, I need to get rid of the fraction. How do I get rid of a fraction? I put this over 1. And now I need to get rid of the denominator. So the denominator here is 1, so I send it over here. The denominator here is y minus 2. I send it over here. Now I multiply this by the numerator, and I get negative 14 equals, multiply this by the numerator, and I get negative 10 times y minus 2. I give the negative 10 to each piece in here. I get negative 10y plus 20. I want to get the constants with the constants, so I will move this 20. And I get negative 34 equals negative 10y. I divide both sides by negative 10. Negative 34 divided by negative 10. The negative divided by a negative gives me a positive. I'll move that over to positive. And I reduce by dividing the numerator and the denominator by 2. I get 17 divided by 5. The answer is 17 divided by 5. Let's do these here. I'm going to do these a little quicker and not explain because we should be at this point now. Oh, wait, I made a mistake. Let me start.
Hey, here.
Draw my line.
Oh my God.
I need to get rid of the parentheses. I get 3m minus 12 equals 18. I add 12 to both sides. I get 3m equals 30. Divide by 3, m equals 10. Hold on, this doesn't look like a 3. Let me redo this part. This next one here, get rid of the parentheses. We get 5y plus 35 plus 5 equals 50. I combine my like terms. I draw my line. Let's try this one here. Okay, so in this question it says, write an expression for the perimeter of the garden below. So remember, we have some juicy words in here. Expression is going to have no equal sign. You will simplify, and you will not get an answer x equals. Perimeter, remember, is, if you have a shape, it's the distance around, and you add all the sides together. Think of it like the fence. So the perimeter of this figure here would be 8. Okay? So that's what perimeter is. Using our knowledge of the word expression and perimeter, we're going to find the perimeter of the garden below. A garden is where flowers grow. So for our expression, we're going to use our knowledge of perimeter here to add all of the sides together. And we will get x plus 3x plus 2 plus 2x plus 5 plus 6x minus 17. So now we want to simplify to get this expression. So I need to combine my like terms. I have a positive x here, positive x here, positive x here, positive x here. And my constants I have here, here, and here. Let's combine our like terms. I add x plus 3x gives me 4x, plus 2x gives me 6x, plus 6x gives me a positive 12x. I combine my constants. I have positive 2 plus 5 gives me 7, minus 17 gives me negative 10. There are no more terms that I can combine. My answer is 12x minus 10. It says for number 2, the perimeter of the garden is 110 feet. Solve for x. Remember, when we solve, we will have an equal sign, and we will get an answer of x equals something. So it says the perimeter of the garden is 110 feet. Well, we just found up here that the expression for perimeter is 12x minus 10. If I want to solve for x, I can have 12x minus 10 equals the perimeter of the garden. Now, this is easy. I just add a 10 here, add a 10 here. I get 12x equals 120 divided by 12 divided by 12. X